Hi. Suppose you're investigating a crime scene as part of a CSI team. Evidence could be substances that are found there, and you must identify them. Is that white powder on the victim's lip baking flour from a donut, or is it arsenic? I bet you'll have to find some of the properties of that material before you can decide. The goals of this lesson is that you'll be able to identify physical properties and physical changes. You'll be able to distinguish intensive properties from extensive properties. And you will be able to identify and compare the three states of matter. The essential questions: when I see a change, how can I tell if it's a physical change? Why do all samples of a certain substance have the same intensive properties? How do I tell the difference between the three states of matter? So we're in Chapter 2 looking at matter and change, specifically the properties of matter. What you observe when you look at a particular sample of matter is its properties. Is a solid shiny or dull? Does a liquid flow quickly or slowly? Is that gas odorless, or does it have a stinky smell? Properties used to describe matter can be classified as extensive or intensive. Remember that matter is anything that has mass and takes up space. The mass of an object is a measure of the amount of matter that that object contains. The mass of this basketball is greater than the mass of the golf ball. The volume of an object is a measure of the space occupied by the object. The volume of the basketball is greater than the volume of the golf ball. Mass and volume are both examples of extensive properties. An extensive property is a property that depends on the amount of matter in a sample. So, a small rock and a big rock, even if it's the same kind of rock, are going to have two different masses. It's not the same for that kind of rock. Intensive properties are the properties that you might consider besides mass and volume. For example, the outer coating of a basketball might be leather or rubber or something else. These have different properties that make basketballs different for different uses. Leather basketballs are ideal for indoor play, but not so good for outdoor play. The leather absorbs water and dirt more than a rubber ball would do. Absorbency is an example of an intensive property. An intensive property is a property that depends on the type of matter in the sample, not the amount of matter. Let's take a tissue paper, for example. A small tissue will absorb water and get wet. A big tissue will absorb water and get wet. It doesn't matter how big or small the tissue paper is, it will still absorb water. As opposed to a piece of rubber, for example, a small piece of rubber will not absorb water, and a big piece of rubber will not absorb water either. It doesn't matter how big or small. That's an intensive property. Matter that has a uniform and definite composition is called a substance. Aluminum and copper are both examples of substances, and they're known as pure substances. Every sample of a given substance has identical intensive properties because every sample has the same composition. Aluminum and copper have some properties in common, but there are differences besides their distinctive colors. And there's some things that are the same. Aluminum is highly reflective, is often used in silver paint, but then so is copper very reflective. Pure copper can scratch the surface of aluminum because copper is harder than aluminum. Copper is a good conductor of heat or electric current, but so is aluminum. Same and same. Copper and aluminum are both malleable, which means that they can be hammered into sheets without breaking. Hardness, color, conductivity, and malleability are examples of physical properties. A physical property is a quality or a condition of a substance that can be observed or measured without changing the substance's composition. Physical properties can help chemists identify substances. For example, A colorless substance that was found to boil at 100 Celsius and melt at 0 Celsius is almost certainly going to be water. But if another colorless substance boils at 78 degrees Celsius and it melts at negative 117 Celsius, that would definitely not be water. It would probably be ethanol or some other alcohol. Let's say you wanted to compile a list of properties of a substance, but you don't have a way to measure mass or volume. What kinds of properties can you determine without knowing the amount of the sample? Pause the video here for a second and think about that. I hope you thought that you could figure out an intensive property, because it doesn't matter how big the sample is, you can still measure its color, its hardness, and other things that are intensive. The three states of matter, solid, liquid, and gas. There is a fourth and fifth state, but we don't see them very often here on the planet, plasma and a Bose-Einstein condensate. A solid is a form of matter that has a definite shape and volume. The shape of a solid doesn't depend on the shape of its container. Liquids are different. The particles in the liquid are in close contact, but the arrangement is not rigid or orderly. The volume of a liquid is fixed. That is, liquid is a form of matter that has an indefinite shape. It flows around, but it keeps the same volume almost exactly. Gases, like a liquid, gas takes the shape of its container, but a gas will fill up the whole volume. And liquid doesn't do that. The liquid stays at the bottom, at least here in gravity. Now in gases, vapor and gas are sometimes used interchangeably, but there is a difference. Gases are things like oxygen that exist in gaseous state at room temperature. And vapor describes some kind of a gaseous state of something that's usually a liquid, like water vapor or gasoline fumes. Those are vapors. Words like boil, freeze, melt, and condense are used to describe physical changes, not just the changes, but how we cause those changes. And so are words like break, split, grind, cut, and crush. These words are ways I can change the physical nature of a substance without changing the substance itself into something else. These are different kinds of physical changes. Every sample of a given substance has identical intensive properties because every sample has the same composition. Three states of matter, solid, liquid, and gas, and physical changes can be classified as reversible or irreversible, depending on whether you can go back to what it was before. Now here's some of the words we've used today. Mass, that's the measure of how much matter something has. We'll measure it in kilograms for ordinary stuff, but in chemistry usually it's grams for small amounts in the laboratory. Volume is a measure of the space occupied. An extensive property is a property that depends on the amount of matter in a sample. An intensive property depends on the type of matter, not the amount of matter. A substance is matter that has a uniform and definite composition. It's either an element or a compound. It's also called a pure substance, but we'll imply purity when we say a substance. Mixtures are the opposite of that, and we'll see that in a later chapter. A physical property is some quality or condition of a substance that can be observed or measured without changing the substance's composition. A solid, a form of matter that has a definite shape and volume. A liquid, a form of matter that flows and it has a fixed volume but an indefinite shape. A gas is a form of matter that takes the shape and volume of its container. A gas has no definite shape or volume. A vapor is the gaseous state of a substance that's generally a liquid or solid at room temperature. A physical change is a change during which some properties of a material change, but the composition, the makeup of the material does not change. Well, chemistry is known as the central science, Physical properties such as melting point and boiling point are used to describe matter. So, and the goals. Do you think you can identify a physical property? If you talk about the property and examine how it interferes or reacts with the stuff, is it going to be keeping the material the same? How about a physical change? If something changes, can you tell it's a physical change by the way the stuff remains the same material? You should be able to distinguish intensive properties from extensive properties. You may remember how the intensive properties depend on what kind of material we're looking at. If we're looking at, say, a rock, and we're talking about hardness, a small rock is just as hard as a big rock. It only depends on being the same kind of rock. But if we're talking about mass, the big rock, that's an extensive property. The mass of a big rock is much larger than the mass of a small rock. And you should be able to identify and compare the three states of matter: solid, liquid, and gas. So, here's the essential questions. I'm going to have you answer these questions either by writing, typing that is, or saying into the discussion group in the properties of matter response assignment that follows this. You're going to answer these three questions in complete, thoughtful sentences as possible. So when I see a change, how can I tell if it's a physical change? Why do all samples of a certain substance have the same intensive properties? And how do I tell the difference between the three states of matter? Remember that in an assignment like this, you're allowed to use any word or phrase from the question in your answer. That's not plagiarism. That's called fair use. So, for example, with the first question, I might change it around and say, when I see a change, I can tell that it is a physical change because, and then I would list some reasons. You see how I've used words and exact phrases from there without quotations. Perfectly legitimate. Thanks for coming round.